and its corresponding stack. Further, after explaining all these, we will provide a hands-on on the DApp development. So let's move to DApp. Basically, DApp development. Kindly mute. Hello, everyone. Kindly mute yourself, please. So, DApp development is an end-to-end application development process. DApps are a piece of software that communicates with the blockchain and manages the state of all the network actors. So in this diagram, you can see that any user can have a DApp with the front end and the back end. So every user is a peer in the peer-to-peer network, and the peer-to-peer network is a blockchain. So any user having a DApp can communicate with each other using the protocols such as Swarm or Whisper in order to communicate with each other. Next, let's let's see what's the basic difference between a normal app, a centralized app that you are using, and a DApp. So as you can see, in a normal app that you generally use on the left side, you can see that the any app can communicate with each other using a centralized server. That is, if an app wants to communicate with another app, it needs to communicate, it needs to go through the centralized server. That is, if app 1 wants to communicate with app 2, the messages will go through the ISP, that is the internet service provider, and then will communicate to the centralized server, and then further will go to the message will be forwarded to the next app. So there is a lot of latency as well as various drawbacks while using the centralized server. On the contrary, we have DApp, where there is no centralized server. That is, in order to communicate from one app to another, the apps can directly send the messages or can directly communicate with each other using that can directly send messages to each other. So we can say that DApps are decentralized in nature. They are connected to each other without any having any central server in between. So as we can see that the client side of a DApp can be a web app. We can have a web app for a DApp. We can have a CLI, that is a command line interface for developing a DApp. We can have a desktop app. We can have a mobile application, or also we can have a IoT device. So we can have all these options in order to create a front end for a DApp. Next, also, I would like to mention one thing here. A DApp can also be generated by a non-blockchain backend as well. So it is not compulsory that we need a blockchain for development of DApp, but generally we use blockchain for development of DApp. Next, next, as explained earlier, uh, this is basically the detailed explanation. What's the difference between a centralized web app that we generally use and the DApp which we are going to develop in this session? So, as explained, the backend and the database in the centralized web server that we are currently using, that we are majorly using in nowadays, basically lies on the server itself. So, in order to communicate with each other, the messages need to go through the server and will be returned back from the server itself. Whereas from the in the blockchain part, in the DApp part, we have front end on the peer itself, and we communicate using the blockchain. We can have smart contract. We can have a smart contract. We can have a blockchain, or we can have a ledger. Next, what are the features of a DApp? So, as we all know that DApps are basically decentralized in nature. So these DApps provide a lot of features so that we can use it over the centralized ones. What are the advantages of that? first is open source. Anyone can contribute towards the creation of a DApp. That is, anyone that has who has a knowledge of Solidity language or who has some expertise on developing a DApp. Next,
Hello, Diksha ma'am, are you there? Hello.
Hello, hello, Diksha ma'am.
hello.
So she is coming in a while. There is some network issue, I think. Yeah, Diksha, you can restart, please.
Yes,
Yeah.
ma'am. Sorry, there was a network issue. So let's start with the features of DApp. What are the features of DApp that we are using it over the centralized one, that we are preferring it over the centralized one? So it is basically open source. Open source means anyone can contribute. Hello, anyone can contribute towards the creation of DApp. Anyone having anyone having the knowledge of DApp creation, anyone having a knowledge of Solidity can contribute towards the creation of DApp. Next, they are decentralized. All records are stored. All records are stored on a public and decentralized blockchain. So there need not be a centralized server in order to create and store the records. DApps can automatically coordinate in order to store. Kindly mute yourself. Hello, everyone. Please kindly mute yourself. Yes. So there is no need of a centralized server in order to create or store any record on the blockchain. Next, they are incentivized, means validators on the blockchain are incentivized by rewarding them accordingly with the cryptographic tokens. Anyone who contributes to the development of DApps or who stores DApps on the blockchain are rewarded with some tokens. It may be in the form of ethers or bitcoins. It can be the person or validator can be incentivized. Next, let's see the DApp architecture. As you can see, the DApp architecture basically constitutes of three parts. First is this the main application that you develop, the front end. Next is this Web3.js, and third major part is the blockchain on which actually the smart contract resides. So, hello, am I audible?
You are audible. Please continue.
So Web3 objects are basically instantiated in a Web3.js script. As you can see, there is a Web3.js script. So Web3 objects are instantiated in a Web3.js script. Requests or calls are invoked on these Web3.js objects. So Web3.js, these requests are transmitted over RPC pipelines. which are basically in the JSON format. These are sent or executed using appropriate API and smart contracts code. Next, after this, result is returned to the web client. Basically, Web3 API basically connects to the local node through RPC ports. In this, here you can see the Web3 JS basically connects to the local node on your system through RPC port, which is basically which creates the RPC pipeline, and which is basically in the JSON format. There are basically two major JavaScript libraries which we use in order to create this RPC pipeline, which are basically dedicated for Ethereum DApps. Those are ETH and Net. Next. Also, I would like to add one more thing about smart contracts. Basically, smart contracts are the codes where all business logic of application lives. As told by Baga sir, he has also given a visualization what actually smart contracts is. Smart contracts are basically his all business logic resided on a smart contract. So, smart contracts are the code where all the business logic of application lives. They are basically in charge of reading and writing data to the blockchain as well as executing the business logic. The function of smart contracts on the blockchain is very similar to a microservice. As we have microservice on the web, uh, similarly we have these smart contracts on the blockchain. Also, you can say that as we have public ledger to represent the database layer of the blockchain, similarly, we can say that smart contracts are where all the business logic resides and that transacts with the data. I hope it's clear. Now let's look at the DApp stack. This is the basic DApp stack. We have basically three main levels of DApp stack. First is platform, next is processing, and the third layer consists of the file system, database, and the e-cache, or you can say e-gold. So what is this? Basically, platform is basically a front end which you use to create in order to interact with the blockchain, or else you can say that in order to create your DApp. Next, we have various platforms like Eris or Monad, or we have block apps. Next, in once a platform is created or a front end is created, you can execute your code. You can execute your business logic on the blockchain, which constitutes the processing level of this blockchain stack of this DApp stack. So this which can also the blockchains on the processing level includes the Ethereum, Hyperledger. It can also include some consensus protocols such as Tendermint, or you can have a Corda platform as well. So once the processing has been done, the you further you can use the file system or databases in order to store your huge data files. As we all know that the size of blockchain is actually limited, so you cannot store huge files on the blockchain. For this, you can do is you can create a hash of your file, and then you can store your hash instead of the transactions, and then store those files on the file system. One way is storing it on the file system. The file system can be anyone. The main file systems which are used nowadays by the blockchain developers which are basically IPFS, Interplanetary File System, and Swarm. Both are basically compatible with the Remix IDE we generally use for Ethereum blockchain in order to develop the Ethereum smart contracts. Next, you can also use a database. You can use either a file system or you can also use a database. So what's the benefit of using a database? As we all know that databases are queryable, so we can use if we have a application which wants that we have to do some query in our transactions. Suppose we have a system which wants to query that. Suppose we take a healthcare application. In a healthcare application, we have non-transactional data, that is patient's ID, patient's where the patient has been admitted, patient's diseases, everything. So all this data will be stored on either the file system or the database. Further, the hash of this transaction, the hash of this whole data will be stored on the blockchain. So in order to query, suppose I want to query that I want the patient's data of this patient ID. So I can retrieve it from my database, from my blockchain database. We have various databases such as BigchainDB or IPDB, which are majorly used by researchers nowadays in order to store their large data files. Next, we have eGold or eCash, which are used for monetary purposes. All this data is pushed to the smart contract using the oracleized facility that we have in the Ethereum smart contracts uh, smart code, or we can say we have in the Solidity language in order to push the data. Next, yeah, BigchainDB. I have a doubt. I have a query in the chat box. BigchainDB is free or licensed? Basically, BigchainDB is free. If you want to use it for a test net, so you can put your queries, you can create a network, you can create a private network or anything you want to create. You can put your transactions in the form of JSON file, and you can create a metadata as well. There is some specific format in which they want your the data to be given in order to store it into the BigchainDB. So they have a test net on which you can put your data for 1 day, and you can put your data for 1 day, and you can also uh, you and after and around 4 a.m. in the morning, every morning the data is vanished out, the data basically cleans out. So you need to if you want to create a permanent blockchain or a permanent BigchainDB software, so you need to create your own dummy blockchain. Next, I hope the doubt is clear. Next, what are the languages to be used for development of DApp? For front end, we will use HTML, CSS, or JavaScript. You can use any language you are comfortable in. Next, for smart contracts, you can have Solidity. Solidity is basically a contract-oriented, high-level language for implementing smart contracts. It was influenced by C++, JavaScript, and Python. It is basically designed to target the EVM, that is Ethereum Virtual Machine. So, in order to develop a DApp, we basically require some dependencies that we need to have in our system in order to develop a DApp. First is Node Package Manager. Uh, we have Node.js in order to control the network. Next is Truffle Framework, Ganache, MetaMask, and you can have any editor you want. You can have any editor, like you can have Sublime, Text, or you can have Notepad++. Next, let's talk about Truffle Framework. So Truffle Framework is basically an IDE that provides from an initial application template to a local blockchain for testing your developed DApp. So in order to once you create your DApp, you can basically test it on your local blockchain using this Truffle suite. This Truffle suite comes along with Ganesha. Ganesha basically allows you to create a private Ethereum blockchain to run tests, execute commands, and inspect the state of the blockchain. So as my co-presenter will explain you, Ganesh will basically gives us 10 external accounts with address of our on our Ethereum local Ethereum blockchain with 100 fake ethers. Next, MetaMask. MetaMask, as already explained by various experts, MetaMask is basically it acts as a bridge between the blockchain server and web. It is like a digital wallet that provides to connect to the underlying blockchain node and manages the accounts, the gas points, and transactions and balances. This all which I have told you will all be explained in detail, and each step-by-step process will be explained by my co-presenter Shubham. So Shubham, can you please continue with the same?
Yes, ma'am. Sure.
Thank you.
Good afternoon, everyone. Hopefully, you guys have already downloaded all the prerequisites that were being mentioned in the last session. Please just mention on the chat done or you need the time for the same. Uh, Can I start? Am I good to go? Because okay.
Yes.
Basically, what we were talking about, as you have already seen on the map's screen, that we will be talking about the DApps, and I will be trying to give you a bit hands-on on the DApp, tell all details or the mergers that ma'am has already shared with you, that how the things are happening. By now, we already have many sessions, so we already know that what the blockchain is, how the blockchain is working, means what the block is, how the blockchain is formed, how many types of blockchains are existing, and the various questions I think already have been answered. Now, in order to use the blockchain's power or something, the most important or the majorly things that is playing the role in the industry is the DApps. DApps stands for the distributed apps, means just like we were having the server systems, right? In server systems, what we were having is we were having the websites. In websites, we used to send a query to the server using the browser or Android application or IoT devices or anything, right? And a response was generated from the server, right? But the issue was the server was one at one place, it was centralized, so you definitely have to trust some third party or something. In blockchain system or the DApp system, what we are trying to do is just trying to replace the server which was generating the response for you. The single unit has been replaced by a blockchain. Means a network is there, a blockchain is there, but it is acting as if only a one server is responding to you. It is very intuitive if you think that uh, server responds to you, a single unit is responding to you, then there is no issues. But if the response has to be gathered from the set of systems or the network of systems, then it is not that easy or that simplified when we come to implement the same, right? So basically, if we talk about the blockchain and the DApp systems, then we can visualize, if I compare it to the traditional web server system, then at the client end, the same client end is working as it was before, but the server has been replaced with the blockchain plus smart contracts. Now, if we talk about the four layers, basically, in which you need to focus or in which any of the DApp is distributed, the four major areas, namely, it's blockchain, which is the for everything. Over the blockchain, smart contracts runs. The role of the smart contracts is to create the response, just like as in the case of the web server, the XAMPP used to do, or ASP.NET or IIS used to do. The same work here is being done by the smart contracts, right? And the next thing is the APIs. The APIs depends upon the system for which we are developing the DApps. Suppose in this case, we are developing for the Ethereum network. So if we are developing for the Ethereum network, then we can use Web3. If we want to design that our DApp should be running on the browsers, is it the web application? If it is an IoT application, then our API will change accordingly. If it is some other application, then again it will change accordingly. All right. Now let's see first of all that how any of the contract is being formed, or let's see the foundation. First of all, let's see the foundation. Foundation is this. As soon as you install the Ganache, the software that I recommended, you will see the whole screen, and there will be the one option of selecting quick start. So I will request all of you to open the Ganache, select on that option quick start. You will see a similar page as I am showing on the screen will appear. Here you will be having some more addresses. I think approximately by default 10 addresses will be appearing to you, and the balance of each and every will be 100. If any confusion still, just post it over here. We are focusing on the base, the base of the thing, that is a Ganache. Ganache is just giving you a dummy blockchain. Hope it's understandable that it's just a dummy blockchain. It will be working in a similar manner as we have learned. Mining will be taking place, everything will be doing, and everything will be done. This is providing dummy blockchain for the Ethereum network. And the IP on which it is running can be seen over here. I'm highlighting by my cursor. The local host port number is 8545, and it is being mentioned as the RPC server. Yes, sir. 10 accounts will be showing, and that's the default setting. You can change going right, but I don't think we need it. This is very much clear that this is the basic what we have. Sorry, sir, you're not audible. Please repeat. Hello.
Continue, please.
If there is any doubt, he can post it on the chat also. Fine. So we are done with the most basic layer. Now the layer that will be working about this blockchain. We have created a network. Need something, some softwares which can be run automatically. If I define the smart contracts are nothing, but it is just the set of codes that can execute themselves automatically, right? If you want to visualize the smart contract, you can also visualize it as a contract that take place in the legal cases. In the legal cases, law or the judge ensures that whatever the contract has been done between the two parties or the two entities is executed properly. The same work is done by the smart contracts over here. It can also be visualized as a server, because for its responsibility is to read the request being generated by the client and generate the response as per the business logic that has been defined in the contract. Hope I'm clear. Here what I am doing is I have made just a small contract whose logic is to change the candidate name. There is some variable which is having some default candidate name, and we will be trying to change this name as per our will or as per our need. Okay, so if you view this contract, the language that we are using is Solidity. It is very much clear. This line, the first line, what it is doing, if you want, you can open the Remix platform. The link is over here. you can just write remix on the Google, and this similar platform will open. Firstly, I think this screen will be available. You can switch to this file window, go on to this plus sign, create a new file, whatever name you want to give, xyz.sol. I have created it by the name election.sol. You can create this file over there. This is, we are creating the smart contract using the Solidity language. Obviously, as many languages are having, no, as we are having the many versions of JDK, as we are having many versions of SDK, similarly, Solidity is also having the many versions. Updates is taking place many days. The first line is just defining that which version we want to use for the compilation of our program. The next line is the contract where we are making the the constructor for this class. This name should be same as the name you gave to it. The next is we are just creating a variable that is the candidate name, or that is of type string. Then I have made a function. In order to go through these syntaxes or something, there are many online tutorials that we can go through. There is tutorial points. There is Solidity official language also, which you can just go through and just have the syntax. It's very much simple to adapt of the OOPS concepts. It's a very easy language. I don't think there is many issues. Anyone from the computer science can easily correlate it. That a function is being created with the name election. What it is doing, it is just allotting a dummy name, that is candidate 1, to the variable candidate. Then the next is set candidate function. This function is also what doing. Whenever this function will be called, I will tell you that when this function is being called. But for now, we can just understand that what this function is doing. This function is taking the entry argument as one of the name, right? And it is changing this variable that we had set with the default value. We are changing it with the name, that argument with the argument with which we call this function. I think this class is very much clear, and now we can see how this we have created a small contract for ourselves. Now we should proceed how to compile the same or how to deploy the same. If there are any doubts till now, you can unmute me because lots of chat messages are there, so I'm unable to see if any relevant query is there.
Hello, sir. Am I audible, sir?
Yeah, sure.
I just clarify my doubts. First step is first download that.
Firstly, you have to download the 2-3 things that I said. Hello. You're no more audible, sir.
Yes, sir. That done. That part. Okay.
Okay.
Hello?
Where is the
second
confusion,
part
sir?
is and confusion is, sir, actually how to provide that Solidity part, that language, that code, contract code, into directly placed into that website, that URL. You are doing something on that will display in the URL part.
You can just type. You want to know where I'm typing this contract, right? You just run this remix, right? Remix form as soon as you search, right? You will get a remix ID over here, right? This is the same link that we are using.
Yes, sir.
Just a minute. This is the ID. Hope it's clear.
Yes.
You will open this file.
Yes, yes, sir.
You have to go inside the file. You have to create a file as per your name. To copy this code. I think the code that I have shared in the drive, it is having this code. There is no need to type. You can copy paste. I've already explained this
Okay,
code.
sir.
Now I'm proceeding how to
Yes, sir, I
compile it.
got it, sir. Yes, sir.
Okay.
Thank you.
Yeah.
So
Sorry, Shivam, there is one more doubt
yeah,
regarding the underscore name string variable. Can you please explain this?
th- that's the argument that is being passed to this function. Set candidate is a function that we are defining that will be taking an argument in form of a string, and that string name is underscore name that is being used over here, and that will be transferred whatever we suppose if I call this set candidate function with the argument shubham, so shubham will be the name, and the shubham will be transferred into candidate name, this variable, and this variable that is we defined as candidate 1 will change as shubham. So proceeding to the compilation, you just need to select this it is third one from here. You need to select the environment from here, mark it as solidity. Then all right now only three windows would be appearing on your screen. As soon as you select the environment as solidity, all these will be appearing. Go to the compilation section, this one. Select the file that you want to compile. All these compiler and attributes will be set it automatically. And then you can select compile the selection, whatever your name is. Hopefully it will be compiled successfully. There are the few warnings because of some depreciated classes or something that we used just for the ease. But warnings doesn't matters. Hopefully error is not there. As soon as we do it, now we can proceed as we have already compiled our code, right? We can proceed to the deployment section. See, the fourth one is deploy and run the transaction. We have to go to this. This window by default would be selected as JavaScript VM. You need to change it to Web3 provider. There might be the question that why we are changing to the Web3 provider. I told you initially that in order to interact, there are the various APIs being provided by the Ethereum. Web3 provider is one, JavaScript VM is another, injected Web3 is other. We are using the Web3 provider because we will try to query or our client application will be running basically on the Chrome, that is a browser. So for the browser, Web3 provider API is there. You can again refer to the all the API section of the Ethereum in order to know that which API is for what purpose.
Shubham, just a minute. When we are selecting the Web3 browser, we are getting external node request, some warning kind of thing.
Yes, sir. I'm coming to it. You just need to accept it out.
Okay.
No issues. The hopefully your Ganache is running.
Yes, yes.
Yeah. It will be just accept it. No issues. Okay. So Web3 browser is being selected. As soon as you select it, you can just check it. When you will check click on this account section, you will see the same users with the same ethers that were appearing on the Ganache. You can verify it by this. See, I am having the two users. One is having the 99.95 ether and another is having the 100 ether. The same is visible from here also. This is the gas limit. That is the amount of the maximum rewards that can be given to someone. I don't think we need to just do anything right now with this. It is the advanced kind of a thing, and we are moving very basic.
Shubham, I'm getting a error while selecting the this Web3. I have done okay, but again I'm
Okay.
getting a message that
Okay.
just a minute, just a minute. Uh, I'm getting a message not possible to connect to Web3 provider. Make sure the provider is running and a connection is open.
Okay. The issue is, sir, because MetaMask is not installed in your. case.
MetaMask is there.
Yeah, I have already mentioned in the prerequisite that you need to okay, and you might need to configure. That is also one might issue will be there. What you need to do is here, as soon as you go to this MetaMask, right? You click over these all the possible networks
Right.
to the custom RPC.
Okay.
Network name, whatever you want to give,
Okay.
and you copy the new RPC URL from this RPC server. Whatever the Ganesh server, it might be running on 7545 or 8545. Whatever is your URL,
Okay. Okay.
whatever is the URL, just copy it over here.
Save.
In custom RPC, yeah, just save it out. Once you save it, the other thing that you need to do is you need to create on import account. Initially, import account might not be appearing. You can just click on the create account. As soon as you click on the create account, there will be the option of import account also. See, import option is here. What you can do is copy any of these private keys, any of the user's private key.
Okay.
Suppose I copy this one. And you just need to paste it over there. Here, import,
Okay.
and paste the private key and import the account. If you see this MetaMask, there are many types of network already available. All these networks are the Ethereum blockchain networks. They can be visualized as a different ports. Means whenever we send a request, suppose I send a request to the Google, www.google.com, it is its IP, right? So its IP is okay, means I want to, IP is something that which system I want to collaborate with. So Ethereum network is something that I want to collaborate with. But inside Ethereum network, there are many types of network. Ethereum blockchain system is containing these types of networks. There are many public. You might create private also. So
Please repeat where to copy the new RPC URL once again.
okay, you have to copy this new RPC URL. You basically have to create a network. Means you have to link your MetaMask. What we are doing is we are linking our MetaMask or the Chrome browser with the local network. We can link it with the public network also, but right now what we are doing, we are trying to link it with the local network. So what we have to do is we have to go to the custom RPC, name this network whatever you want to name it. RPC URL will be pasted over here, and then we will be saving it. As soon as you save it, I have saved it with the name Ganesh. So it is appearing over here, Ganesh network. Once the network is being saved, once a communication is being established, we can create an account for any of the users who are already available on the Ganesh on this blockchain network. As initially I told, it is a dummy blockchain. Hopefully this connection of MetaMask has been done.
Yeah.
The issues of compilation and deploying would have been resolved now. If all is being set, you can change this to Web3 and you can click on the word deploy. I have seen deployed over here. It will appear like this. Two buttons, candidate name, set candidate. This is something text box like where we can give input. And this is the candidate name. So if I check the candidate name right now, it is showing as Ram. Suppose I want to change it. What I will be doing it, I will be writing Shubham over here. We are just trying to visualize that how, the smart contract that which we have created, how it is running on the debugger. Right now, we have not created any DApp, any application we have not created. We are just testing the business logic of our smart contract. That the business logic of our smart contract is working fine or not. We have written Shubham over here. Now I will click on this button. As soon as I click on this button, which function will be fired? This function will be fired. What it will be doing, it will be changing this variable's name to the Shubham, as Shubham is the input that I'm giving. It is being done. Now when I click this function, candidate name, then which function will be fired? This function will be fired. What is the role of this function? The role of this function is to display whatever is being saved in the candidate name. Right now, earlier it was Ram, but now Shubham has been saved. So as soon as I click this button, this will change to Shubham. Let's see. Yeah, it's working fine. Absolutely fine. But right now, all the things are just happening on the debugging level. We have checked that we have a smart contract. We know it's working fine. Now let's see how to link it to the blockchain, right? We must link it to the blockchain so that any of the web application, any of the user can interact to this via this smart contract, and they can make the changes to the database that is actually your blockchain. So for this, I will leave all the things over here and try to create a front end. In order to save the time, I've already forwarded you the files. This is the simple front end that I have created. We all know that HTML via HTML, we can interact with any of the web server or something. What here we will be interacting with, here we will be interacting with our blockchain. Hopefully, everyone knows basic HTML. I know that there are people from the electronics background, so let me brief a bit. It's a very simple language in which just the opening tags and the ending tags are with the same name or something. This is the HTML tag within which all the code will be lying. This is the head, that is a title, that is a candidate Shubham over here. Suppose. What is this? I will show you. Let me open this with the Firefox. Okay, I'm having here. You can see the tab name where my cursor is right now. Just a minute. This tab name is becoming candidate Shubham. If I change this code, if I write it as a candidate or I just name it as Shubh, there only Shubh will be appearing. This is a simple thing. It has nothing to do with the blockchain or something. Nothing to confuse with. See, it has changed to Shubh. Right. So it's fine. I don't think there is anything to explain. Even if I eliminate this tag, nothing will happen. Everything will be running fine. Only that will be removed. This is the body. In body, what I have done. In body, there is one header, which is where candidate name is being hard coded. You can see this is the candidates that has been hard coded. The effect of this line is that a text box is being created. This one, a text display. We have nothing hard coded over here. We have just given the ID over here. We have given the ID over here so that we can change the text that needs to be typed over here, over here dynamically. Sorry, but I cannot. I will not be able to see the chats and doubts. I can take the doubts later on. H1. Okay, the form is being filled. The form is having the two fields. One is the text box, and other is the submit button. All right. Hopefully, the front end code is totally clear to you. Nothing is there. It is just the HTML that is creating this page. nothing else. Now let's see, using this page, how I can interact with my smart contract, the smart contract that which we created right now. For that, we need to include two scripts. These are the two scripts which are needed. There is no answer to this, why this script is needed or why I think. You can just refer to the API, because whenever we are having the API, we know what the full form of API is. We have to follow the rules and regulation being given by the API provider. So these two scripts must be included. Simple as that. If you are designing the Web3 application. Actually, these lines are telling the page that Web3 browser should be Web3 enabled. Means either this browser should be the Mist browser, or if it is not a Mist browser, it is a Chrome browser or Mozilla, then MetaMask must be there so that it is capable of dealing with the Web3 APIs. Hope I'm clear with it. The next thing is script. In this script is actually this tag. If I tell this tag, the tag that I closed and the tag that I'm opening, this is the tag which is mainly responsible for creating the connection between the smart contracts and this front end. What you are doing over here, the smart contract that we created, if we go over there, we go to the compilation section. In the compilation section, you will find two types of codes over here. One is the bytecode, another is ABI. ABI is nothing. It is the application binary interface, and bytecode, as the name only tells, that it is a byte. It is a bytecode for the compiled code that we have created for the soft code. When we are dealing with the Web3 API, we have to copy this ABI code, which will be in the JSON format. Bytecode is needed. Suppose we are doing the Ethernet wallet or something, then the bytecode would be needed over there. But right now our application is being limited to ABI. So let's copy this ABI. You just need to copy this ABI. Everyone needs to do it. My pre-written code will not be working if you don't do this. You will have to copy this ABI file. You have to copy this ABI file and just change whatever is being written in this JSON. You just need to change it. You can just delete it and paste the code that was given to you. That is given by your remix ID. The next thing that we need to do is we again need to make a variable. See, it was a variable that we made with the name contract ABI. Here we save the JSON file that we copied from the smart contract. Here what we are doing is another variable we are creating, that is a contact address, right? And contact address, from where we can copy, it will be given in the form of string. You can copy it from, you need to go to deploy section. In the deploy section, where you are running this code, this section, see here is a template, a button which is showing copy value to the clipboard. You just need to copy the address from here. You just need to copy the address from here and paste it here as per your need. Again, this change needs to be done by everyone. As soon as you fix these two variables, as per your customizations, whatever things you have done till now, this is the line which is setting the contract. Setting the contract means, what is the contract? What is the business logic that you want to be ensured? And who is initiating? At what address this contract is being initiated? This is being creating a new variable for you, that is variable contract. Hope everything is clear till here and it is making sense. Next thing is contract.candidate. This is the function. This is the function which is responsible for displaying anything on your this network, this one, whatever is appearing over here, this that the portion that I've highlighted, it is being controlled by this function. Very much clear that candidate name is the ID that we gave to that text. See over here, ID is given as the candidate name. The same thing we are doing over here, and we are changing its value as per the variable that is being stored from here. Next, this is the function which tells what to do when you press the submit button. This submit button, that is add candidate. By default, if we make any of the button as a submit, any of the people who are having the bit knowledge of the web development must be knowing that submit button by its own refreshes the whole page. So if I write over here Ankit, press the button, this will go into that. See what happens. Name has been changed as Ankit. Now in the smart contract where candidate was being saved, now Ankit is being saved. Hope it's clear. If any doubts till here. If any doubt is there, then you can unmute yourself and just let me know. So I'm just doing a quick recap till now. Firstly, we created a Ganesh. We created a dummy blockchain over here. Then we needed to have a MetaMask or a MetaMask enabled browser or directly the Mist browser, which is capable of dealing with the Web3 JavaScript. Once this is being done, we write our smart contract, compiled it, deployed it, checked it locally first of all, then copied the credential like that of address and ABI code so that we can interact to this smart contract using our front end, that is the web interface. As we were targeting to make a web interface, that's why we use the Web3 JavaScript API. If we would have been targeting some IoT devices, if we were targeting some Android application, if we were targeting something else, then the APIs will change accordingly. I think connecting with MetaMask, change the address, I think it's taking time. Should I wait or should I proceed? Please respond in the chat or just unmute it and let me know.
Yes, Shubham, you can proceed, please.
Sure, sir. Sorry, ma'am. So this was the very basic thing. I think we worked on the 4 layer. The blockchain layer is being done. The smart contract layer is being done. The front end is being done. And the front end can be opened in the browser. So MetaMask is also being configured. These are the 4 sections which needs to be kept in mind whenever you are making any of the DApp. Now, let's move towards a bit complicated one. Not very much, but yeah, a bit higher level. Here what we are doing is I have made a contract again in order to transfer the money or receive the money from someone.
Shivam, can you please again explain how to connect MetaMask and blockchain? Print it
Okay,
out to someone.
sure. MetaMask, you just need to open this window. You need to make sure that the network to which your MetaMask is being connected is the local network. So you, by default, it's not available. You need to go to the custom RPC. Here you can name it whatever name you want to give it. I have given it Ganesh. Then you need to type your local IP, that is 127.0.0.1, and the port on which your Ganesh is running. You can just copy this IP from here also, RPC server IP. Once you copy this RPC server IP, you can paste it. You can paste it over there and just save that network. Once you save that network, suppose you saved it by name XYZ or Ganesh, whatever, then you can select this network. Right now, my MetaMask is being connected to the Ganesh network. Now, what I need to do, I need to import account. I need to import account of the node that is already running on this network. How I can do that? I have to go to this, click on this key, any of the random. You are having 10 users, any of random, just click on the keys. Copy this private key and just paste it over there. You need to import it, sorry. Import it. If you're doing first time, this import account option will not be available. You can import by clicking on this photo. Once you click this photo, something like this will be available. You have to import the account. If you are running first time, the import account will not be available over here. You have to click on the create account. As soon as you run on the create account, there will be the option of import like this. Here, obviously, you are having the private key, so you have to select the private key. Paste the private key over here and click on the import. This will, that's it. That's only needs to be done to connect your Ganesh and the MetaMask. Now I was on this code. This code I have not forwarded on that drive. You can copy it from here or type it on your browsers. If you see over here, there is a constructor. Let's just deploy it and let's see what's happening over here. So again, the same steps. I will go on the compile. I will select the file that needs to be compiled. It is showing compile my contract.sol. This is the file that I want to compile. So I'll compile the file. As soon as the file is being compiled, there are just a few warnings. Again, the same case because I'm using few depreciated classes. Then we need to go to the deploy and run transactions. As soon as we reach this section of deploy and run, if you want, now let's change. We can have a JavaScript this time. As soon as we specify the environment at the JavaScript VM, means whatever the byte Now let's deploy it. This is the contract being deployed. Value is there. There is something telling you as an initial amount, then the initial value. Say initial amount is 100. You can just try going through this, exploring this thing. The one thing that I would like to mention over here is that the contract that I've created this, my contract, which is to transfer the money or something, the initial value is being 1000. The amount that you want to transfer or something, you can mention it and you can transact it and you can do everything. I just copied this code from the tutorial points. But the issues, I took this code just to bring something in your knowledge that whenever we are designing the smart contracts, whenever we are designing these things, then we need to make sure each and every small things in the mind. Like there is no such check being maintained over here that if my value is getting in negative, suppose I'm having 1000 rupees, this functions allow me to even send 2000 rupees. I'm having 1000 rupees, still it is allowing me to send 2000 rupees. Reason being, there is no check being applied to check the available balance before doing any subtraction or addition. So whenever you're writing the smart contract codes, all these things needs to be taken care, all the critical conditions, all the environmental conditions. Whatever we did right now, whatever linking that we were doing right now, we did it manually. There is a framework known as Truffle. Truffle can be visualized just as a Django or the Flask for the web development in the Python, or it can be visualized as a framework like that of WordPress, Magento, the people who are do the development of the PHP or anything like that. Using the framework of the Truffle, what the ease will be there. I think we are very short at time. I cannot show you the whole Truffle things or damn thing. So the only thing is everything is simple, everything is similar. The changes that we made at the front end, this one will be done automatically for you if you do that via Truffle. So it will allow you to make more complex applications, and that is what the basically the roles of any of the framework is. Obviously, Bootstrap and many other Ajax and many other things are already enabled in that framework. So your view will not be looking as simple as this. You can create CSS, you can use animations, you can use these things just by just using the libraries. You don't need to have many extra efforts. That is what the advantage Truffle is having with you. So the way we can create the DApps, I think I can classify into the three ways. Firstly, the way we did, I think it's best for the beginners so that we can visualize that what actually is happening. What is the role that a smart contract is playing? What is the role that a MetaMask is playing? What is the role that the Web3 or any other API is doing? The other is for the professionals, obviously the industrial users that do with a Truffle or something else. The people who want to focus on the actual how, or they want to provide some improvement for the blockchain itself. They don't want to use the blockchain as a use case or something. They want to contribute to the blockchain itself. Then there are many libraries like that of get. Many get commands are there. You actually needs to understand the actual mechanism of all the RPCs in any of the blockchain server. See, Ethereum is one blockchain system. Ethereum is one blockchain system and it is having many networks inside it. One network is this private network that we have created right now, which is running on the Ganache. And there are many public networks too. The real network as well as the test networks. You can see over here. See, main Ethereum network. In order to do any of the transactions over here, obviously you have to spend the money. Then there is a Rosten test network. This is for the development. It can be used by the developers. You can transfer the money to yourself. You don't need to make any actual finance transactions. You can just go over there and make the request over it and do the things as per your need. So it's for learning purpose, it's for development purpose. Similarly, Coven test networks are there. Rinky, Guerrilla test network. I haven't used these three networks, so can't tell much about it. So if I correlate these networks with the existing management of the public IP or the private IP, then it is similar that these networks are available publicly on the Ethereum system. So whatever IP or RPC server IP or port these networks are using, we cannot create any other public with the same IP or something. Otherwise, IP conflict will be there. And same rule applies to the private too. Suppose I want to make two Ethereum network within my Ether system, then obviously I will have to change my IP or the port. Suppose one network is running on something and the other would be running on some other. Any questions or doubts till now?
Sir, after triple network, I won't see the output, sir. Can you show me output, sir?
Sorry, sir, of which?
After triple network, I won't see the output, sir.
Truffle I haven't used till now. Truffle I was just briefing about that what actually the truffle is. Truffle is actually the framework. See, if I want to develop a PHP website, right? I can show you right over here. Suppose I want to develop a PHP website, right? Just forget about the decentralized application or the blockchain application or any other applications. Suppose I want to make a PHP website, then there are two ways, right? Either I can use some framework like that of Drupal or Weblizer or something else. If I use it, many of the things will be automatically done for me. I don't have to create this project structure or something. All these things will be done for me. See, this is being manually created one. But
Okay, sir,
I
okay.
can show you some of Truffle. I will be having the examples of Truffle. I will show you. Just a second. See, see this one. This has been made using the Truffle. You can see that how complicated it is. I didn't pick it up because if I open any of these files, right? If I contracts is another thing, but if I open the source or index or something, see, I am opening this index file. There will lot of bootstrap, lots of Ajax, lot of CSS, right? That has been involved, which will create a confusion, especially for those who are not from computer science background. That's why I decided not to pick this thing. If you do it, you can just refer to any of the online programs or something. You have got the basic concept that actually how the linking is being taking place between all the layers. And I think it will be very useful if you start using and downloading the codes from GitHub or doing anything, and then you will be able to correlate all these complex programs, that how and what actually is happening.
Shubham?
Any other questions?
Yeah. Hello. Yeah. The work we did with the election type of thing, the contract name, the candidate name. So what was the
Sorry,
purpose
sir,
of?
your voice is a bit slow. Can you please?
Okay. Hello.
Yeah.
Is it okay?
Yeah.
Yeah, the whole process that we did with the election one. So we have compiled the contract, we have deployed the contract, and we have copy
Yes.
pasted the some things into the code, in the blockchain code.
Yes.
So in all that process, what was the purpose of Ganache comes into play?
Ganache was providing you a dummy blockchain. Okay. You can increase or decrease the number of users, number of nodes that you want in the blockchain.
Okay.
If you imagine just a normal web client server or website server, let's take example of Google or anything. What happens is you open your browser, right, sir? You type the URL. As soon as you type the URL and hit the enter, what you're doing? You're requesting something to the server. Server receives this request and creates a response accordingly, right? This is a centralized system. But when we talk about the blockchain, everything remains same. When we are making the DApps on the blockchain, everything is remain the same. The only thing is we removed that central server. We replaced it with a network of systems. It appears as if a central system is interacting with you, but actually a network of systems are interacting with you. I cannot connect the 10 to 5 laptops, right, and make a blockchain and do the. If I want, I can do it. I can do it definitely. I can do with the command prompts that I can create a network, a local network, 5 to 6 networks, and then I will have to make few people sit over all these 5 systems and mine the things or do the things appropriately or write the Python codes that will automatically do the mining and other stuffs for me. So I can definitely do that thing. But Ganesh is a easier thing to do it because our main focus is the DApp. That's why we were doing this. Question is there how to create the own blockchain for the research point of view to add the own algorithms, right? Okay. Again, the answer to this will be I think both the ways the things are possible. Either if you are having so much hardware and things having to things and you want to really want to view it, then definitely you can create the networks manually. The private networks can be
If that
created
much
and the things.
hardwares are not, if that much hardwares are not available, then in that case, means if I have to hashing algorithm or any algorithm, so how I can?
Ma'am, if you visit the GitHub and all, there are many codes are available over there where people have done tried to do the similar thing. What actually they are doing is they are trying to create the dummy things on the basis of statistical data or something. Suppose I know that in the Bitcoin every block is being generated after 10 minutes or something, so I code myself. I write the scripts accordingly that after the 10 minutes or 5 minutes the things will be changing. Or if I want to check that the if I keep changing the block length, if block length I want to vary from 5 kb to 10 kb, then I can write a program now which will create a random value from 5 to 10, and we can assume it as a block size being that is being generated, and statistically and mathematically we can do those things. That would
If I want to just change the hashing algorithm, so what is the procedure for then?
sorry ma'am.
I want to just change the hashing algorithm. Instead of SHA 256, I want to use SHA 3. So how I can do that? I don't have that much hardware and that much interest.
You must be having some motive, right? You must be having some objective in order to do that. It is not like that that I just want to do it. Either you want to measure that what efficiency will take place, or how much security will be compromised if I am changing SHA 256 to SHA 3, or some motive might be there. So accordingly we will write the code, and there are the software like GNS2 also. on which you can simulate these things. It's just like we used to do in NS2 or NS3 for the distributed system. Similarly, for the blockchain, GNS is there. Network simulator, we call it.
Genus.
GNS.
Can you type that?
Network simulator. G for Gangtok,
Okay.
N for network, and S for simulator.
Okay. And I have to check the means how my algorithm is better than that. So how I can compare that system?
Sorry, ma'am. Please pardon the question.
I have to make a comparison between my algorithm and whatever existing algorithm. So what is the process?
Algorithm, what? Consensus algorithm or some other algorithm you are trying to propose? Some at network level you want to propose some algorithm, or application level? At which level you want to propose the algorithm?
Related to hashing, I consider then that time.
Okay, but ma'am, why you want to do it with hashing? We are already using the elliptic curve in the hashing, which the normal public-private key concept that was.
Better, but I have to just check that. For example, so how I can do that?
How can you do that? Okay. You want to create a hashing algorithm and you want to do it things. One web API that we were using just to simulate the things, you can make the changes over there. You can shift the SHA algorithm as per your requirement. SHA 256 applied over there, right? And then you can track the time of mining or something that is being taking place in your case, and obviously in 256, and then you can measure a difference, kind of difference from both the things. That suppose in the
friends.
Hello.
Hello.
Yes, ma'am. Hello. Hello.
Yes, sir. Continue, please.
Sure. Okay. I hope I have answered your doubt. Means you can just go through these things, and we can have a no mathematical measure. Suppose for the 100 thing, if it's taking 4 nanoseconds, then for 10,000 or something, statistically or something, only you can assume. I think no other options I am knowing available till now. Is there any tool to compare the consensus algorithms?
Okay. Thank you, sir.
Sure. Is there any tool to compare consensus algorithms? I think it's the thing of distributed system, consensus algorithms. If you want to compare, obviously we can. I think we can compare the things on these network simulators, and we have done also the things that using the network simulators we implemented consensus algorithms in lab while doing the distributed things. So we can do it by them.
Any more sessions, please? Any more queries, please?
Hello, sir.
Yeah.
Suppose I want to keep my relevant data in secure through blockchain. Suppose healthcare data. Suppose I want to secure, keep secure in blockchain. Then which platform is better and how to use that normally? Suppose if I am using Hyperledger, suppose Hyperledger, that type of Fabric 2.0, let's.
I think, sir, it's very it's a very generalized kind of question. Sorry to interrupt in between, but I think it's very generalized kind of a question that you're asking, that healthcare, because health, actually it is not the healthcare, I think, that will decide that which will be the appropriate or not. I think it's a type of data basically on which you should decide that which blockchain system you should be going for, or which something which kind of mechanism will be suiting to you. And moreover, the applications also matters, that how much latency your system can allow. If your healthcare system is something which needs to be done in the real time or something, and you cannot afford the latency, then obviously you cannot go with any of the blockchain systems which are supporting proof of work or proof of stake. Then definitely you have to go for some DBFT or something like those kind of implementations, right? So I think many factors are there. Which type of data it is, image data is there, video data is what you want to store, and even in the storage there are the many types of storage being possible. There is offline storage, there is online storage. If your data is small, it's a transactional data or something, you can prefer the online storage. And then if it's an image or something, then definitely you have to use the offline storage method. Your data will be relying somewhere in the distributed network over the offline, and your hash will be saved on the blockchain just to make sure the reliability.
So for your query, you can use one thing. You can do is you can store your data on the file systems or database, and you can store your hash on the blockchain as explained. I hope it's clear.
Okay, ma'am. Okay, ma'am. Thank you.
Thank you. Any more doubts before we call this a session?
If no doubts, then we can call off the session and go for the lunch.
Yeah, thank you so much, Shubham, for such an informative session, for providing a hands-on to everything. I hope the
Thank you, ma'am, for the opportunity.
I hope the participants have got insight of how actually everything is done. So let's call off this session and go for lunch. And we will again meet at 2:30. So every one of you is please requested to to join us at 2:30 so that we can continue with the feedback and further with the quiz. Thank you so much.
Thank you, ma'am. Thank you.
Thank you. Thank you.
Thanks to all. Thank you.